We have three massive updates. Anthropic just made a surprise move and extended the free window for Fable 5, and OpenAI has a lot to do with this. Meta dropped what might be one of the most mind-bending breakthroughs in years, an AI that can decode brain activity into typed text with up to 78% accuracy. And a new Chinese lab, Tencent, just launched an open-weight model that is genuinely challenging Opus 4.8 and Fable 5 in real-world tests. We just can't miss any of these. And without wasting any time, let us get straight into it. Let us start with Fable 5 because the deadline everyone had circled on the calendar just moved. Fable 5's free access window was supposed to end July 7th. That deadline got pushed back. Anthropic quietly extended it to July 12th. If you are on a paid plan or using Claude Code, you now have 5 more days to run this model without paying extra usage fees for up to 50% of your weekly usage limits. After July 12th, Fable 5 moves entirely to usage-based billing at $10 input and $50 output per million tokens, roughly double what Opus 4.8 costs. So if you have heavy testing to do, this is the window to do it in. Now, why did Anthropic do this? The most likely answer is competitive timing. OpenAI is gearing up for the public release of GPT-5.6 Sol. By keeping Fable 5 accessible a little longer, Anthropic gives developers less reason to jump ship the moment OpenAI's new model lands. It is a defensive move and a reasonable one. And if you have not been using Fable 5 yet, you are missing something genuinely different. It does not behave like a standard chatbot answering one prompt at a time. It plans, it delegates pieces of a task, it executes multi-step work, and finds its own failure points along the way. It is built for exactly the kind of messy, complex pipeline most models fall apart on. If you have refactoring, database migrations, or heavy agentic workflows sitting in your backlog, this is the window to run them. But as impressive as this all is, what Meta just published takes the whole conversation somewhere none of us was expecting, reading our minds and thoughts. So, can you really read the thoughts of your wife? Let's have a look. As you move to the most crucial portion of the video, do tell me, which AI is your absolute favorite? Plus, hit that like button and press that lonely subscribe button as well. Now let us talk about something that has taken AI to an entirely new level, reading human mind and thoughts. Meta's Reality Labs just published research on a system called Brain2Qwerty V2, an AI model that reads brain activity and translates it directly into typed text. Decoding thought with any real accuracy has historically required brain surgery. To get a usable signal, researchers implanted a neuroprosthesis directly onto the motor cortex. It works, but it is invasive, expensive, and nearly impossible to scale to more than a handful of patients. Meta's approach is completely different. It is non-invasive, using magnetoencephalography or MEG, a scanning technique that measures the tiny magnetic fields our brain's electrical activity produces from outside the skull. The specific hardware here is a 306-channel cryogenic MEG system, an enormous scanner that has to be kept at extremely low temperatures to detect those magnetic fields at all, which is one reason this is a lab tool right now and not something we could own. Here is how they built it. 9 healthy volunteers had their brain activity recorded for 10 hours each while actively typing, producing a dataset of around 22,000 sentences. Each session followed the same pattern. A participant heard a sentence, waited for a cue, then typed it out, with the letters never displayed on screen and no backspace allowed. That gave Meta a clean, controlled signal to train on. Now here is where it actually gets interesting, because this is not one AI model doing the whole job. It is 3 separate systems working in a pipeline. The first is an encoder, and its only task is to look at the raw, noisy MEG signal and pull out patterns that seem related to text, essentially finding a needle in a haystack of magnetic field data. The second is an aligner, which takes those extracted patterns and connects them to word-level representations, mapping fuzzy brain signal chunks onto something closer to actual language units. The third, and this is the part that made the biggest difference, is a large language model, fine-tuned specifically on this neural data. That LLM does not just ask what letter this particular signal might represent, it asks what word makes sense given everything around it. The same kind of contextual prediction that powers modern autocomplete, except here it is reading brain activity instead of previous keystrokes. Meta's research also describes using AI agents during the research process itself, running automated experiments to test different pipeline configurations and find setups that outperformed a default baseline. So AI was not just the end product, it also helped build the system that decodes the brain signal. That 3-stage pipeline, encoder to aligner to language model, is why noisy brain data becomes usable text at all. Raw MEG signal alone is far too weak and inconsistent to decode directly. It is only once a language model layers real linguistic structure on top of that signal that the guesses start turning into coherent sentences. The results are genuinely striking. Average word accuracy across all participants landed at 61%. For context, earlier non-invasive brain reading methods struggled to hit even 8%. For the single best participant, Brain2Qwerty reached 78% word accuracy, meaning more than half of that person's decoded sentences had one word error or less. Two real hurdles remain before this becomes something we could actually use. First, accuracy still needs to climb before it is practical for daily communication. The encouraging part is that Meta's data shows a clear scaling pattern. Accuracy improves log linearly as more data gets added, and they have not hit a plateau yet, which suggests today's numbers are an early point on a curve rather than a ceiling. Second, that 306-channel scanner is not going anywhere anytime soon. Wearable MEG sensors, specifically a newer type called optically pumped magnetometers that run at room temperature, are in early development, but that is a future capability, not a current one. Meta is releasing the full training code for both versions of the model and funding a $5 million digital brain project to encourage open neuroscience datasets. This could genuinely restore communication for people living with strokes, brain lesions, or locked-in syndrome. But as we will get into in the honest section, it also raises real questions about personal privacy that we should not wave away. Now let us shift entirely, because the third story today is not about brains at all. It is about a Chinese lab that just quietly dropped a serious challenger to two of the biggest names in AI. While Meta was reading brains, Tencent quietly released HY3, an open-weight model that is turning out to be one of the bigger surprises of the summer. HY3 is a mixture of experts model with 295 billion total parameters, but it only activates 21 billion per token. That architecture gives it roughly a 40% improvement in inference efficiency compared to prior models, which means real intelligence at a fraction of the usual compute cost. Tencent released it under the fully permissive Apache 2.0 license, so it is free to download, run locally, or access through OpenRouter. Developers have been putting HY3 through intense front-end coding tests, and the results are genuinely turning heads. In one-shot challenges, it built a working macOS desktop clone, a functional 2D game, and an interactive 3D solar system simulation. It handles layout, color theory, and visual hierarchy with a level of polish we usually only see from Anthropic's top-tier models. On STEM benchmarks, the picture is even more interesting and more precise than a simple beats everyone headline. On Frontier Science Olympiad, which measures scientific reasoning capability, HY3 actually leads both GLM-5.2 and GPT-5.5. On BrowseComp, a search agent benchmark, it sits essentially level with Claude Opus 4.8 and GPT-5.5. Those are genuinely strong specific results, not vague marketing claims. But here is where we need to stay honest, because the gaps that remain are real ones too. On SWE Bench Pro, the hardest coding benchmark, Opus 4.8 still leads clearly, 69.2 against HY3's 57.9. On Terminal Bench 2.1, Opus holds a solid lead as well. And on Math Arena Apex, GPT 5.5 is well ahead of HY3. So HY3 is not simply better across the board. It has specific strengths, front-end design, scientific reasoning, and search agent tasks, where it genuinely competes with or beats the biggest names. And it has specific weaknesses, deep coding and advanced math, where the closed models still lead. For developers, this is still a real win. A free open-weight model that can handle agentic programming, visual front-end work, and STEM reasoning at this level without a subscription changes the calculation for a lot of everyday work. Now let us have an honest conversation about all three of these updates, because behind the excitement there are real caveats worth sitting with. First, on Fable 5. Getting 5 extra free days is genuinely useful, but let us not lose sight of the bigger picture. This is a temporary extension, not a reversal. Once July 12th passes, Fable 5 moves to usage-based billing, and it is expensive to run casually at that point. Enjoy the extra runway, but plan your workflows now so a surprise bill is not waiting for you on the other side. Second, on Meta's brain reading AI. This is a genuine scientific breakthrough, and it is also worth taking the privacy concerns seriously rather than treating it as sci-fi paranoia. Right now, the technology is limited by massive scanners and healthy volunteers who are actively, consciously typing. But the scaling data suggests accuracy keeps climbing, and wearable sensors are already in early development. What happens when this technology can decode more than deliberate typing? The boundary around our inner thoughts is not being crossed today, but the direction of travel is real, and it is worth talking about cognitive liberty and neural privacy protections now, well before the hardware catches up to the ambition rather than after. Third, on HY3, the results are genuinely impressive, particularly in front-end work and specific STEM benchmarks like Frontier Science Olympiad, where it actually beats GLM 5.2 and GPT 5.5. But it is not a clean upgrade over everything. Its context window is smaller than Fable 5's, which limits how useful it is for massive multi-file code bases. And for pure coding depth specifically, SWE Bench Pro and Terminal Bench still favor Opus 4.8, and GLM 5.2 remains the stronger overall choice for backend architecture and complex debugging. HY3 is best understood as a brilliant free option for front-end and scientific reasoning work, not a universal replacement for the coding-focused open models. So friends, the move here is simple. Use Fable 5 on your hardest problems over the next 5 days. Watch where Meta's brain research goes, because it is scaling faster than most people expected. And if front-end work or scientific reasoning is on your plate, HY3 is worth testing on Open Router while it remains this accessible. Tell me in the comments, how are you going to use Fable 5 within this extended window? And would you give HY3 a try? Share your opinion in the comments. I'll see you in the next one.